Hi everyone, welcome to Beyond Space, even at the Tundra. In today's episode, we'll talk about NASA's Perseverance rover, and more specifically about one of its scientific instruments called Moxie. It is an experiment aimed at demonstrating how we can produce oxygen from the Martian atmosphere to later use it for breathing and also as a fuel. So our next guest is Michael Hecht of the Massachusetts Institute of Technology, who is the principal investigator for Moxie. He'll provide some details regarding this interesting experiment, as it is an instrument that could be crucial for future human exploration of the Red Planet. So without any further ado, please welcome Michael Hecht.
Thank you, Tomas.
Hi, Michael. So to get started, if you could present in general, tell about what is Moxie and how it works, how we can use it on the Red Planet.
No, I'd be happy to. When we send people to Mars, there are, of course, several things they'll need there that we'll have to bring with us. They need a way to land. They need a way to take off and come back, which is very important, of course. And they'll need a place to live. They'll need a way to get around. They'll need power. Those are the big five. And we have to be very frugal, of course, about what we bring with us, because it's expensive, it's complicated, it's risky, and the more, a launch is full of stuff that has to all rendezvous at one point, the harder it gets. So the question is whether we can use resources that Mars provides us already to satisfy some of the larger needs. Well, it turns out that the largest single need that these astronauts will have is for oxygen, and not for the obvious reason, not because they need it to breathe. Of course, we need oxygen to breathe.
But it's mainly for fuel, right? To use it as
almost.
Yeah.
Almost, yeah. Fuel is essentially used colloquially, but technically, it's to burn the fuel. So the 4 astronauts might use a ton of fuel in their 1.5-year stay, maybe a ton and a half.
Right.
But the rocket that lifts them from the surface, just like people, the rocket has to breathe, and for the same reason, we breathe to burn our fuel, which we call food. The rocket breathes to burn its fuel, but it has to carry that breath along with it. It has to carry the oxygen with it. So the oxygen is not the fuel, it's the oxidant. I was pleased to see that as in the New York Times crossword puzzle on Sunday, had the clue: substance a spacecraft uses to burn its fuel, and the answer was oxidizer. So what we are trying to do is provide that oxidizer, and it's a lot. It would be an estimated 25 tons or more of oxygen to burn the propellant, to just take the astronauts off the surface.
For one rocket, right? For
one rocket for 4 astronauts.
Yeah.
That's it. That's
a lot.
So if you did grant things like SpaceX is talking about doing, it would be far more. And so the question is, can we avoid having to bring that? And the answer, of course, is yes. And why do I say of course? Well, there's a lot of CO2 on Mars. The atmosphere, although it's very, very thin, is almost entirely carbon dioxide. And we know on Earth, if we look around us, if I look out my window, there are trees and plants and grass, and they're all busy turning carbon dioxide into oxygen. So we know it can be done, and we can also build a little machine to do it, and that's what Moxie is. It's a small demonstration scale machine. It's not full scale, and it can do about what a medium-sized tree can do, in that little box.
So so convert carbon dioxide into oxygen, right? So it's it's a technology demonstrator. They will need a larger devices, like larger instrument to do it. But it's like the first step for further research into that, right? Into converting those resources on Mars into those needed, like oxygen and something more, right? So it's the first first major step to do it for further future I don't know, future missions to Mars, human exploration of Mars, and even more. So If you can, we can now talk more specifically about the experiment on the Moxie instrument on the Perseverance rover. So, do you have some first results from this experiment, something like that? Is it already converting carbon dioxide into oxygen?
I don't have actual first results for you. Let me describe a little bit how the mission's proceeding. We landed, of course, back in the middle of February on the 18th, and we're spending the first month of 6 weeks checking everything out. So everything means Moxie, 6 or 7 other experiments that are more Mars science oriented, a robotic arm and a coring device that's going to drill, everything involved in driving, all the cameras and the navigation equipment. And that's what's going on. And that includes Moxie. So we have checked everything out. And that means everything but making oxygen. So we've made sure our compressors that draw in the carbon dioxide work, and our heaters that heat up this oxygen conversion unit to 1500 Fahrenheit to 800 C, that works. And the voltage, we can apply the voltage we need. That all works, all checked out. The only thing remaining is actually to show we can make oxygen. And we're waiting, like every other experiment, to have a chance to do our science thing. In the meantime, we now are going to spend a month to 6 weeks experimenting with a helicopter. That's also a really exciting new technology on board Perseverance. So I hope to be able to report to you first oxygen within a small number of weeks.
Yeah, so talking about Moxie, this small device, how much oxygen could it produce? Some kind of quantity.
It's a small device for a couple of reasons. One is that it doesn't have to be big to demonstrate that the technology works. It also can't be big for two reasons. One is the obvious. It's a small rover, right? Only so much can fit in the back seat. And the other reason is that it takes a lot of power to do this, just to rip apart those carbon dioxide molecules. Trees do it by collecting, sunlight and using photosynthesis. And that's why they have to be so big and collect lots and lots of solar power. The rover only has a little tiny power source, and this is really important. It's about 110 watts. It's like an incandescent light bulb. That's it. That's what's driving this thing around. We will need to do a full-scale Moxie system, something like 25 or 30,000 watts, kilowatts, 25 or 30 kilowatts. That's what a human base will need anyway. But for now, we can only demonstrate what we can do in that little tiny 100-watt supply and a battery. So with a battery, we can run a few hundred watts for a few hours at a time. And that's what we plan to do. And we're doing it because we shouldn't get too overconfident in our own ability to make critical technology work in another planet without trying it out.
Yeah, right. So it's just an initial demonstration, and some maybe of.
So you asked how much oxygen it's going to make. I didn't answer your question. In terms of numbers, it'll make about 10 grams per hour, roughly speaking, a little more, a little less. And that's roughly about half of what you and I breathe when we're just kind of sitting quietly. It's what a small dog might use to, happily go about its life.
Sounds cool. Looking a little bit farther, so if we can think about, I don't know, maybe some crazy ideas about terraforming Mars to more, I don't know, more Earth-like planets to convert all the carbon dioxide. It's something like Moxie can answer this question, so we can in some kind of a distant future try to terraform this planet, and the Moxie could be I don't know, show us how to do it. Maybe we can send a swarm of Moxies there to make it more Earth-like, more habitable.
Well, let me, in a sense, we're going down a road, and I'm thinking about what happens over the first hill, and you're 4 or 5 hills down. So let me try to fill in a couple of the intermediate ones. And I'd like to, when people ask me about terraforming, my kind of facetious answer is, can we learn to terraform the Earth before we terraform another planet? And there's a point to that, other than just being witty. The point is that we've damaged our own environment here on Earth, and we should learn how to fix that before we learn to change the environment of another planet, in my opinion. But more to the point, what is the future of this ISRU, of this ability to produce oxygen? Well, in my view, once we have a stable base on Mars, even a relatively small one, even something like McMurdo Station on Antarctica, we can start thinking about traveling, and we can start thinking about looking for resources. And the single most important resource on Mars for a human base is water, not air. Because if you have water, you can make oxygen, and you can make hydrogen, and you can combine them with carbon dioxide, and you can make beer if you want. Right? These are the basic elements. And to get water, you simply need to travel several hundred kilometers, maybe 1,000, 1,500 kilometers, depending where you land, and retrieve it directly from the permafrost. It's just below the surface. Fill up a truck, melt it, fill up a truck, because it's ice, it's not water. Melt it, fill up a truck, drive it back, and you have all the water you need. We can't expect in the near term either our rovers or our astronauts to do that. But I do think that's where the oxygen and hydrogen will come from in the sort of future you're talking about, not from taking the little bit of air that's left and converting it. It's not enough. Even if we did, it wouldn't be enough to provide our oxygen needs on a planet-wide basis anyway.
Yeah. Okay, Michael, thank you so much for taking part in this event, for all the answers and shedding more light on this instrument. Once again, thank you, and it was a pleasure to host you on our
Thank
event.
you. Thank you very
so
much. I'd be happy to come
you.
back once we've made oxygen.
Yeah, thank you. Thank you. Bye.
Cheers. Bye-bye. Have a good day.
Bye. Have a good day.